date year ಹಾಕಿದ್ದೀರಾ?
Our definition. National Animal Health currently getting the Ayurvedic diagnosis depending only one person, like assessment, creating different of patient diagnosis. And there are three major addresses of problems which are accessibility gap, subjective challenges, and integration difficulty. Accessibility gap, it means limited to qualified Ayurvedic practitioners in many regions where various diagnosis, treatment of recommendation in patient systems, and subjective challenges in Ayurvedic diagnosis depending heavily practitioner and experiences, and it is consistent and recommendations of patient systems, and it is using a machine learning models, integration difficulty. It is hard to difficulty of ancient holistic rules and Ayurvedic qualified diagnostic data. Objectives: bring the ML model. We are doing the ML model. We are feeding the lot of information about symptoms like lot of information. Database architecture. Design is gathering information on patients' data in history of patient data in Act of HLPPA, Health Insurance Portability and Accountability Act, and user interface in creating institutional diagnostic questionnaires of presentation of both traditional Ayurvedic and medical languages, and security appliances. It implements HLPPA complement data handling of encryption protocols.
Now I am going to discuss about the detailed improvements of our project. In phase 1 we have done a market analysis and research, and we have known the basic information of Ayurvedic and used the person requirements gathered for Ayurvedic system, and we have searched for technologies which are required for developing our project. And initially the architecture system was designed based on flowcharts. In phase 2 now we are going to expand the training data set from 5,000 to 50,000 Ayurvedic case studies. We are going to take feedbacks from practitioners or like doctors or students from Ayurvedic institutes. We have increased the data privacy based on HIPPA compliances. HIPPA is a set of rules or instructions which are used to protect the patient's sensitive information. Here we use UIX design, improved UIX designs. We implemented a multi-language support which helps in the patient for the rural language or distant language. System design and architecture. Here we have the main 5 stages: patient input, AI diagnosis, engine, data processing, inference, security, medical output. In a patient input, here we take input from patients such as their names, symptoms, and the reported lifestyle habits. In AI diagnosis, engine, it is an AI engine process which is used to analyze symptoms of a patient and improve the recommendation for the dosing imbalances. Data processing. This is the stage which is used to normalize, encrypt and validate the data and maintain privacy and accuracy before it fed to diagnosis model. Inference security. We have increased to ensure system security through APIs, authentication, encrypted storage, which safeguards sensitivity of medical records of the patients. Clinical output. The final output delivered detailed records on Ayurvedic treatment, which are required for treatment.
Here is the implementation data. We are creating the random forest for analyzing this product. The step one is create and save product. What are the required for releasing the output? There are one is body type, second is decision, and so on. There is diagnosis and and we have created this create PDF form. It is for converting the data set creation and next is print the data set created successfully from model training. The step 2 is to load and pre-process data. Here that we can load the data set as it file Ayurvedic diagnosis CSV. It contains minimum of 5,000 data sets. Here the label encoder. This is used to convert the data set into numerical value by the label encoder. For that we can convert the body type, decision tree, so on. It converts, it transforms into data to numerical value. Then it is train the model. We are using the random forest tree for predicting the output, and we are splitting that text data and the train data, and step for evaluating auto performance. We are here while predicting the while training model for prediction. We are classifying that while prediction while test data set to frame and report to make a report.
See, implementation mistakes is not the complete code, isn't it? Even on a complete code,
Innovation.
only next.
Basic data set code. Case 3 clear.
Every code complete backward.
ಇಲ್ಲ ನೋಡಿ ಏನೇನು ಇಂಪಾರ್ಟೆಂಟ್ ಅದು ಏನಿಲ್ಲ
ಅದನ್ನ ನೀವೇನು ಇಲ್ಲ ರಿಸಲ್ಟ್ಸ್ ಹಾಕಿದ್ರೆ ಓಕೆ ಫೈನ್ ನೆಕ್ಸ್ಟ್ ರಿಸಲ್ಟ್ ಹಾಕಿದ್ರೆ ಇದು ನಿಮ್ಮ ಡೇಟಾ ಅಲ್ವಾ ದ ಡೇಟಾ ಸೆಟ್ ಇಸ್ ಟೇಕನ್
Here the step is we are using that label encoder. We have converted the text data into numerical data in the label already taken. By this predicted new case, we are generating new prediction by using the data. Then new input data set, we are predicting that by using the data type for decision we input. Just
here you have shown the data set is created right the data set created successfully for the model training ಅಲ್ವಾ what is it SLDP ಇದೆಲ್ಲ zero ಇದೆಯಲ್ಲ So what is the data set size then? ಎಷ್ಟು data set ನೀವು upload ಮಾಡ್ಬೇಕು data set ನ ತಗೋತೀರಾ?
ನಾವು 5,000 ಕೇಸ್ ಸ್ಟಡಿ ಮಾಡಿಸ್ತೀವಿ.
Why study?
5,000 ಈ ನೆಕ್ಸ್ಟ್ ನೀವು ಮಾಡಿದ್ರೆ ಇದು 5,000 ಮಾಡರ್ಸ್ ಡಿಸೈನ್ಸ್ಗೆ ಐರನ್ ಕೋಡಿಂಗ್ ಏನಂತಾರೆ ಮತ್ತು ಅವೆಲ್ಲ
Data set ready ಇದೆಯಾ?
ಈ source
It complete part.
and we are using this type of data set and it will be pretty good.
Just a minute, I will. So this is just one sample. Let's see the citation. So are you doing a recommendation? Recommendation?
ಅದೇ ನಮ್ಮ ಡೈರೆಕ್ಟ್ ಶಾರ್ಟ್ ರೆಡಿ
ಇದು ಏನು ಕೊಡುತ್ತೆ ನಿಮಗೆ ಡೈರೆಕ್ಟ್ ಶಾರ್ಟ್ ಕೊಡುತ್ತೆ.
Next major challenges and solution we are
ರೆಕಮೆಂಡೇಶನ್ ಮಾಡ್ಬೋದು
ಅದು ಸೇಮ್
ಅದು ಇದೆ
here we will first one major challenge is limited data set availability. Since there is no proper and Ayurvedic data set, we created a synthetic data set and with the help of research paper and consultation of experts and next complex formulation of it. Converting complex Ayurvedic terms into the machine readable graphic. Here we created the designing feature and encoding synthetic clarity symbols. And next model overfitting. Our early models were overfitting and worked very only on training data and we used a cross validation and visualization technique to enhance the normalization. And fourth challenge is UI integration issue. And in this the backend and front end several communication errors will appear and will be resolved by streaming component structure. In future work-time express
What is that string? Where you have shown?
streaming buttons, charts,
String structure.
and it contains the buttons, navigations like charts where we can UI integration connect with
UI
backend. Next future work and next placement and the third phase we collecting real user data, real patient data that can be patient can enter the data sets and which symptoms that occur and model will help the diagnostic predictions and give prescription and suggestions over the IoT and integrating a chatbot interface. Here chatbot interact with the patient system easily and enter symptoms and get back to the IoT suggestions in natural language. And conducting model testing and validation. The model will be tested accurate, larger and more diverse data sets which is performance are accurate will be more and validation ensures the AI system provides consistency with the predictions and implementing deployment through the web platform. And we deploy our project in cloud server which is the access anytime and high scalability. These are the references we use.
So here, up till now, what work has been done?
Take